generally, you guys have performed quite well, but just a few techniques that you may need to know. So that's why I have a few comments here. So first, read the questions carefully, just like class practice 14.1. So some of you have written just the chemical equation, but have not written the ionic equation. So for example, in class practice 14.2, you have the hints: magnesium hydroxide and the zinc oxide are insoluble in water. But some of you still regard these two chemicals to be soluble and have split the ionic compounds into two ions and cancel out the ions in the left hand side and the right hand side. Okay, so I regard that as a careless mistake. So also, in question number 30, you are required to name the gas Y, but some of you have given the formula instead. Okay, so these kind of mistakes are quite silly. Okay, careless mistakes. You know the question, but you have not followed the instructions, that you cannot get the marks. Right? That is not a very good practice. So also, in part B, you are required to suggest a chemical test. Also, you are required to explain the observation of the test. So some of you have just suggested a chemical test to identify gas Y, but you have not explained the observation of the test by indicating the calcium carbonate produced is insoluble. So here, the observation is milky, so you must tell the others it's because the calcium carbonate produced is insoluble, so that's why the solution turns milky. So question number 34. Also, you are required to name the ion, but some of you have just given the OH minus as the answer. Secondly, this is a quite disappointing error, repeated error. So for class practice 14.3 B, C, and D, there is a reactant which is insoluble solid ionic compound, and I have repeatedly emphasized that insoluble solid ionic compound cannot be separated into two ions, and therefore, even the left hand side you seem to have that ion, and the right hand side you also have that ion, but since they are in different states, so that's why you cannot cancel out each other. So for question number 30D, although sodium hydrocarbonate is sodium hydrogen carbonate is in solid state, but it is soluble in water after the water is added. So that's why we still need to separate the two ions and do the cancellation when we are writing the ionic equation. So another point you need to note is the question works. So if you are asked, usually describe how something, usually you are required to write the procedures. So that's why in question 34A, you need to write in the details of how we can prepare the lime water until the final product is obtained. So add sodium, add solid calcium hydroxide to the water, and stir the mixture for a long time until no more solids dissolve. You need to tell the others how you can repeat the same procedure. So some of you also stop here and do not tell the others. You need to filter the suspension to get a clear filtrate for the use of the lime water. Okay, most of you have missed this sentence. So also check your answer with common sense. For example, question number 30E, heating solid sodium hydrogen carbonate can also help to generate gas Y, which is the carbon dioxide. You are asked to write an equation for this process. So many of you guess the products are sodium oxide or sodium hydroxide, and then write a balanced chemical equation. Although your balanced chemical equation is correct, stop and think about the common daily life principle. You are baking a bread, right? You are making a bread, right? So how could that process produce such a strong base? Sodium oxide and sodium hydroxide is a strong base. The bread you need to eat the bread, right? So it is impossible for that process to produce such a strong base, or otherwise all bread feeder will die due to of the strong alkali being swallowed into our body. Okay. So that means sometimes even chemically, theoretically, the answer is correct, but you need to check with whether your answer contradicts with the knowledge or the facts that you have encountered in your daily life. Okay. So at last, answering technique is to be sharpened in order to get full marks when you are answering the questions. So I have told you before, when you are writing observable change, so since it's talking about a change, so that's why you must be telling the others both the original color and also the final color. Also, in question number 30, water ionizes a solid acid. We do not accept dissolve, I have told you during the lesson, because water really ionizes the acid, because originally the solid does not contain any ions. So if you just say dissolve, you have not told the others, you know that the solid acid is ionized. So you have lost the marks. So also you need to tell the others after the ionization, it gives out the important hydrogen ions, which is responsible for the acidic properties. And then since you are asked to explain what is the function of the water, so that's why you need to talk about the reaction a little bit in details. So it reacts with the sodium hydrogen carbonate so that it gives out the carbon dioxide gas. Okay, then it will be used to make the bread spongy. Okay, because now the observation is the purpose at last is to make the spongy bread. So that's why when you are explaining the role of the water, you also need to explain until this purpose is achieved. Okay, so this purpose is achieved because carbon dioxide gas is produced. But why carbon dioxide gas can be produced? That is due to the hydrogen ions react with the hydrogen carbonate ion. So why there are mobile hydrogen ions? That is because water can ionize a solid acid. So in question number 32, some of you understand the principle, but you write that if you wrote that magnesium ion is insoluble in excess sodium hydroxide, that is a little bit strange, because the ion is originally dissolving into the solution. This is a solution, so you said that it is insoluble in excess sodium hydroxide. That is a little bit strange. You better write it like this. White precipitates are formed upon addition of excess NaOH. But some of you have missed this excess. Then all the observable changes that you are describing, like the precipitates we dissolve, is not valid because you have not mentioned that excess sodium hydroxide is added. Okay. Also, for zinc 2+ is soluble in excess sodium hydroxide is not very good presentation way. You better present it in zinc 2+ forms white precipitates first, and then the precipitates we dissolve upon the addition of excess sodium hydroxide, so that it looks like the zinc 2+ is soluble in excess sodium hydroxide solution. So I have I cannot say that it is wrong, but usually we present it in this way because that is actually what happens. So zinc ion first give the precipitates, and the next it will dissolve.